good morning everyone. So today also I am continuing the determinant chapter. So in the last online class we did question number 12. So today, in the last class we did not only question number 12, we did question number 1, question number 2 and question number 12, and we have to do again the previous problems before 12 also. Okay, now let's do question number 4. So now I have left question number 3 out there, you can do it at home. So after I finish this question number 4, then I'll give you the homework, right? That is, I'll give you the question of question number 3, that will be your homework. Okay, it is same as question number 12 that you have done in the last online class. So let's do question number 4. You have to prove this determinant is equal to second determinant is equal to that third determinant, right? So let us write extreme left hand side, that is, let us write D is equal to first row ABC, second row XYZ, and third row is PQR. So here also you have to prove this first is equal to second determinant without expanding. Prove without expanding. It is asked in the question, you have to prove without expanding, right? So let us see this second determinant, what is to be proved. Now this XYZ is in the second row here, but you have to take that XYZ to the first row out here, okay? And PQR here is in the third row, PQR here is in the second row, and ABC are in the first row out here, but ABC are here in the third row. Now how can you prove it? You have to interchange the rows, right? So here in this case you can use property number 2. So what does property number 2 say? It says that the sign of the determinant will be changed if two rows or two columns of a given determinant are interchanged, right? Now let us interchange first and the second row here. XYZ now goes up in the first row and ABC comes here in the second row, right? So let us interchange first row and second row. But you have to change the sign also. According to property number 2, you have to change the sign also. This is minus. Now XYZ becomes the what? First row. What will be the second row? ABC. What will be the third row? Third row as it is. Here it is kept same, right? Now again, so XYZ is in the first row. XYZ here is also in the first row. That is okay. Okay. Now ABC, in this case it is third row. PQR, in this case it is second row. Now you have to interchange this second row and the third row. Use the same property, property number 2. So in that case, if you interchange the second row and third row, this minus becomes positive. You have to change the sign. So let us interchange second row and the third row. Therefore D is equal to, this minus becomes plus now. So first row, keep it same. Now what is the second row now? PQR, PQR, and what is the third row now? ABC. That is, first part is proved. That is, XYZ is in the first row, PQR is in the second row, and ABC is in the third row. So it is proved. Is it clear to all of you? Okay. So now let us prove from here, that is from the second determinant, the third determinant. Yeah, third determinant ma chahi ke cha bhanda first row ma YBQ, second row ma XAP, and third row ma ZCR. Let us prove this third determinant from here. Just now we have proved this determinant, this one. Now we have to prove this is equal to this. Is that clear? So now, as a next step, so what will you do in the next step now? Therefore D is equal to, now look at the second determinant which is to be proved. Now y is here. YBQ, right? This is YBQ, XAP, ZC, R is there. Actually here Y is in the first row, right? Or Y is in the first column. So let us interchange rows into columns and columns into rows. We are using now property number 1. What does it say? The property number 1 says that the value of a determinant remains unaltered if rows are changed into columns and columns into rows. So here let us change rows into columns and columns into rows, right? Now first row becomes the second column, first row becomes the first column out here. First row becomes first column, right? X, Y, Z. Now second row becomes the second column out here. So it is what? P, Q, R. Now third row becomes the third column. That is A, B, C. Now is it alright? Okay. Now in this determinant which is to be proved, Y is in the first row and X is in the second row. Now let us interchange this first row and the second row. So according to property number 2, you have to change the sign also. Therefore D is equal to minus. Let us interchange first and the second rows. So now first row will be YQB, second row will be XPA, ZRC, keep it same. Is that clear? So now in the next step, again the answer, we are not getting the answer here. Now what happens is that now B is in the second column, Q is in the third column. But here Q is in the second column and B is in the third column. That means you have to interchange this second row and second column and third column. You have to interchange this second column and the third column. Again here also, if you interchange second column and the third column, this minus sign becomes plus. We are using same property, that is property number 2. So therefore D is equal to, so here also if you interchange second column and the third column, you have to change the sign. Minus becomes plus. So first column as it is, Y, X, Z. Now this third column becomes the second column, B, A, C. And this second column becomes the third column, that is Q, P, R. That is Q, P, R. Okay? Understood? So we have proved this third determinant. That is proved. That is first determinant is equal to second determinant is equal to third determinant, or first part is equal to second part is equal to third part. So I think you have understood it. You can copy it. Okay. So let's do another problem. Now, let us do question number 5. Now, this question number 3 is your homework. This is page number 174. So, this question number 3 is same as question number 12, which we have done in the last online class. Okay? Now, let's do question number 5. So, what does it say? This, you have to prove this left hand side is equal to 0. So, what is the given determinant out here? 1, what is this? Omega, omega square, omega square 1, and in the third row there is omega square 1 and omega. You have to prove is equal to 0. What is omega given here? Omega is an imaginary cube root of unity. So you know what is omega. You have done it in class 11 while doing the chapter complex number, right? So if omega is an imaginary cube root of unity, you can write down that there is two formula. One is omega cube is equal to 1 and 1 plus omega square is equal to 0, right? So let us write down this condition first. Okay, since omega is an imaginary cube root of unity, comma, then since omega is an imaginary cube root of unity, comma, then what can we write? Omega cube is equal to 1 and 1 plus omega square is equal to 0. So these are the two formula, right? This is from the complex numbers. So let's prove LHS is equal to 0. So now let us write down left hand side. That is D is equal to left hand side. So therefore LHS, D is equal to, what is D out here? D here is 1 omega square, right? Then comes omega square 1. Then comes omega square 1 and omega. So let us do it. But you have to prove it without expanding. You cannot expand it. Here also in number 3 also you have to prove without expanding. Expanding you have to use the property here, right? So now in this case you have to use property number 5. What does it say, property number 5? That is, if you write R1 plus R2 plus R3, let us see what happens. R1 plus R2 plus R3, okay? 1 plus omega square. This is omega plus omega square 1. That means 1 plus omega square. Same expression is there. Omega square plus 1 plus omega. That is also 1 plus omega square. Same expression is there. That means you can take common from the first row. That means you can use here property number 4. So you can do R1 dash is equal to R1 plus R2 plus R3. Let us check what happens to the columns. So if you write C1 plus C2 plus C3, if you write C1 plus C2 plus C3, what happens is that is column 1 is changing here. How does it change? 1 plus omega square, right? In the first element of the first column, you will have the new element out there, 1 plus omega square, right? And in the first element of the second row, you will have again 1 plus omega square. Same element is there. Again in the third row, in the first column, you will have 1 plus omega square. Same expression is there. Here also you can take common 1 plus omega square. That is property number 4 is used here. So either you can use the property in terms of row or in terms of column, right? So now let us write down the property in terms of column, right? C1 dash is equal to C1 plus C2 plus C3. We are using C1 dash means new column 1. C1 dash means new column 1. That is, column 1 is changing. You C1 plus C2 plus C3 say old column 1, column 2 and column 3. Okay. So we are using the property C1 dash is equal to C1 plus C2 plus C3. That is, column 1 is changing, right? So therefore D is equal to, now what will be the new first column? 1 plus omega square, right? 1 plus omega square. Now what will be the second element of the new first column? 1 plus omega square, 1 plus omega square. Here also the third element of the first column will be 1 plus omega square. That means these three terms are added and we have written here. That is the third element of the first column, right? And others, second column and third column, keep them same. Second column and third column remain same, right? Omega square 1, next omega square 1, and this is omega. Is it clear to all of you? Therefore D is equal to, now you can write down the formula, because in the question it is given that omega is an imaginary cube root of unity. So we can write 1 plus omega square exactly equal to 0. So instead of 1 plus omega square, you write 0, 1 plus omega square 0, 1 plus omega square 0. Okay? Omega square 1, this is omega square 1, this is also omega. So all the elements in the first column is 0. If all the elements in the first column is 0, no need of expanding it, directly you can write 0, because it is known that 0 will come. If you expand it, plus 0, minus 0, plus 0, you know how to expand it now, isn't it? The 0 into any number is always 0, no need of expanding it. Because in the question it is asked without expanding, you have to prove this left hand side is equal to 0. Okay? So no need of expanding it, directly you can write d is equal to 0, because this is 0. Okay? That is, directly you can write, therefore d is equal to 0, because all the elements in the first column are 0. Is that clear to all of you? So the answer is proved, right? Or अब तिमीले यो 0 0 0 नलेखेर यसो पनि गर्दा हुन्थ्यो यहाँदेखि फेरि यो स्टेप गर्दैछु ल. Therefore d is equal to, you could have taken common out here. You could have taken common out here also. You can take common also. That is 1 plus omega square. Right? And what is the new first column now? 1 1 1. Second column and third column remain same. That is omega square 1, and next omega square omega square 1 and omega, right? So therefore d is equal to, what is this value? 0 into, now this is 1 omega square 1 omega square 1, and this is 1 1 omega. Is that clear? That means therefore d is equal to, no need of expanding this determinant now because there is 0 here. Any number multiplied by 0 is always 0. So d is equal to 0, proved. Understood? So I think all of you have understood it. So this is the answer. So now we will do question number 6. You have to prove this left hand side is equal to 0 without expanding. So this is an important question. This is a very important question. You might get this type of question in higher secondary examination. Okay? So without expansion, you have to prove this determinant is equal to 0. Let us prove it. So let us write down the left hand side as d. So d is equal to, this is b plus c a1, c plus a b1, this is a plus b c1, right? So in this case you have to use the property of determinant. The कुनै पनि determinant directly 0 हुन्छ without expansion. कति बेला, if two rows or two columns of a given determinant are identical, then the value of that determinant is 0. This is property number 3, third property, right? So now let us do this question. So now look at the blackboard. यहाँहरुले के गर्दा चाहिँ सजिलो हुन्छ त्यो हेर्नुपर्छ, पहिला चेक गर्नुपर्छ, वरिपरि हेर्नु पर्यो। अब यो सबैतिर नै हामीले आँखा दौडाउनु पर्यो, के गर्दा सजिलो हुन्छ हेर है। Suppose if you do c1 plus c2, this is column 1, column 2, column 3, row 1, row 2, row 3, right? If you do column 1 plus column 2, column 1 is written first, that means column 1 is changing, right? So if you do c1 plus c2, what happens to this first column? You will get a plus b plus c. This is also c plus a plus b, that means a plus b plus c. Same expression is there again here also, a plus b plus c. all these A plus B are same in the first column, that you can take common, right? You will get 1, 1, 1. So this first column, so after taking common, this first column and third column are same. That means you can use property number 3. The value of the determinant is 0 if 2 rows or 2 columns are identical. So what we will do here is, let us use this property number 5. C1 dash is equal to C1 plus C2. Actually it is C1 dash is equal to C1 plus K into C2 ho. तर यहाँ K को value is 1. K may be any constant, right? It may be 1, it may be 2, it may be 3, it may be a fraction also like that. But in this case, this K is 1. Is it clear now? So now let us change this first column using the property C1 plus C2. So let us do this one. Therefore D is equal to, now what is the new first column? C1 dash means column 1 is changing or new first column, right? So B plus C plus A means A plus B plus C, isn't it? B plus C plus A means A plus B plus C. Again, C plus A plus B means A plus B plus C. Again, A plus B plus C, A plus B plus C, right? Now, second column and the third column remain same. That is A, B, C, 1, 1, 1. Now you can take common, use problem number 4. That is D is equal to, D is equal to, what is common out here? It is A plus B plus C. Now, what is the first column? 1, 1, 1. What is the second column here? A, B, C. What is the third column? 1, 1, 1. Right? Now, this first column and the third column are same. That means what is the value of this determinant? 0. So therefore, D is equal to A plus B plus C into 0. So what is the reason behind it? Since 2 columns are identical. Since 2 columns are identical. Since 2 columns are identical. That means A plus B plus C into 0 is 0. That means D is equal to 0. Proved. So without expanding, we proved this result. So this is very, very important. Understood? You can copy it. Now again, we are doing question number 7. You have to prove this LHS is equal to RHS without expanding. Prove without expanding. So here in the first column there is A minus B, B minus C, C minus A. There are 2 elements here, and in between these 2 elements there is minus sign in the first column. This is 1, 1, 1, this is A, B, C. Now here you have to prove first column A, B, C, second column 1, 1, 1, third column is B, C, A. You have to prove LHS is equal to RHS. So let us prove it now without expanding. Okay. So write down D is equal to left hand side. A minus B 1A, B minus C 1B, C minus A 1C. Okay. But you have to prove this result. Okay. So यहाँ चाहिँ हाम्रो के दुईटा एलिमेन्ट आयो. यसलाई चाहिँ एउटा एलिमेन्ट मात्रै बनाउनु पर्छ. त हामी कसरी बनाउँछौं? यो फर्स्ट कलम र थर्ड कलम सबट्र्याक्ट गरेर. किन सबट्र्याक्ट गर्दैछौ भन्दाखेरि किनभने A minus B minus A gets cancelled, you will get minus B. Here BB gets cancelled, minus C. Here C minus A minus C gets cancelled, you will get minus A. That means we are making the single elements in the first column. That means you have to use the property here. So what is that property that you can use here? That means we are changing column 1, right? So column 1 change with this C1 dash is equal to C1 minus C3. C1 dash is equal to C1 minus C3. That means, now, what is D now? D is equal to kati bhayo? A minus B minus A gets cancels, you will get minus B. Similarly, B minus C minus B minus C, C minus A minus C minus E. Is that clear to all of you? We are using C1 minus C3. A minus B minus A minus B, B minus C minus B minus C, C minus A minus C minus C. And second column, write down, what is the second column? Remains same. Third column remains same, A, B, C. Is that correct? Okay. Next, what will you do? Next, you can take common here. Minus is taken common here, isn't it? So therefore, D is equal to, from the first column you can take minus common. So minus is taken common. What is the first column? B, C, A. All are positive now because minus sign is taken from the first column. All these minus sign become plus. And write down second column 1, 1, 1, and A, B, C remains same. Okay? But you have to prove this result. In the first column there is ABC. In the second column there is 1, 1, 1. And in the third column there is BCA. Now you have to change first column and the third column. You can use problem number 2. You have to change the sign. If you interchange first column and third column, isn't it? That is problem number 2. If you interchange first column and the third column, that is third column becomes the first column and first column becomes the third column. This minus sign changes. It becomes plus. So next, from here, this is step. So D is equal to minus sign becomes plus sign now. If you interchange first column and third column. Now first column, new first column is ABC. Second column as it is 1, 1, 1. And what is the third column? BCA. So are we getting the answer? A1B, yes, first row, B1C, second row, C1A, third row. We got the answer. That is proved. Is it clear to all of you? You can copy it. अब हामी question number 9 गर्दैछौं है. Prove without expanding again. You have to prove this L.H.S. is equal to R.H.S. That is D is equal to 0. So this is also very important problem. Okay. So let us write left hand side as D is equal to, what is left hand side? 0 A B minus A 0 C minus B minus C 0. So in this case you cannot use problem number 5. C1 plus C2, R1 plus R2, R1 plus R2 plus R3, C1 plus C2 plus C3. You cannot use that property. That is, you cannot use problem number 5 in this case. So there is different method here. So what we will do here is, you have to use problem number 1. What does this say, problem number 1? Problem number 1 is the value of a determinant remains unaltered if rows are changed into columns and columns into rows. Okay. So now let us change rows into columns and columns into rows in this particular determinant. Right? Let us change it. So therefore D is equal to, now this first column becomes the first row. 0 minus A minus B. Now this second column becomes the second row. A0 minus C. A0 minus C. Then next, what is the third row? This third column now becomes third row. BC0. Is that right? Okay. Clear ba? I mean your first row 0AB like first column बनायौं 0AB. Your second row minus A0C लाई हामीले second column बनायौं minus A0C. अनि यो थर्ड रोलाई -b -c 0 लाई हामीले के बनायौं -b -c 0 थर्ड कलम बनायौं ठीक छ यो थर्ड रोलाई हामीले के बनाउँदैछौं थर्ड कलम अब हामी के गर्छौं यो फर्स्ट रोबाट पनि माइनस कमन निकाल्नु सेकेन्ड रोबाट पनि माइनसै कमन निकाल्नु एक्चुअली यहाँ माइनस कमन छैन बट यु क्यान टेक माइनस कमन हियर थर्ड रोबाट पनि माइनसै कमन निकाल्नु एक्चुअली यहाँ पनि माइनस कमन छैन बट वी क्यान टेक इट माइनस कमन okay so let's do it let us take minus common from all these rows from the first row second row as well as the third row therefore d is equal to minus अब यहाँबाट पनि माइनस यहाँबाट पनि माइनस यहाँबाट पनि माइनस how many minus sign are there 3 minus sign are there so what is their product minus into minus plus plus into minus minus so d is equal to minus the first row बाट पनि माइनस कमन निस्क्यो कति भयो 0 a b सेकेन्ड रोबाट माइनस कमन निकाल्दाखेरि this a becomes minus a so that if we multiply this minus into minus plus plus a has then comes 0 minus 0 कहिले पनि लेख्दैन किनभने 0 is neither positive nor negative right अब यहाँ माइनस कमन के भयो c ठीक छ हैन नेक्स्ट अब यहाँबाट नि माइनस कमन निकाल्दैछौँ त माइनस कमन निकाल्दाखेरि यो प्लस बिकम्स माइनस minus b this plus c becomes minus c and this one is 0 understood okay so therefore d is equal to write down minus sign now what will you write for this determinant what can you write for this determinant actually this is determinant d isn't it we had assumed 0ab minus a0c minus b minus c0 as d. There also same determinant is there. Check this two determinant. 0ab, there is also 0ab first row. Minus a0c, there is also minus a0c as the second row. Minus b minus c0, this is also minus b minus c0 as the third row. Right? So same determinant is there, isn't it? So instead of this determinant, we can write d. That is minus d. Okay? Now let us take this minus d to the left hand side. It becomes plus. That is d plus d is equal to 0. Therefore, what is d plus d? 2d is equal to 0. That means d is equal to 0 by 2. That is d is equal to what is 0 by 2? It is always 0. Good. That is d is equal to 0. That is LHS is equal to R.H.S which is equal to 0. बुझ्दैछ नि सबैले त यो पनि कपी गर्ने तिमीले खातामा राम्रोसँग प्र्याक्टिस गर्नु यो पनि एकदमै इम्पोर्टेन्ट क्वेशन हो So now, problem number 11. Here also you have to prove this LHS is equal to RHS without expansion. So here also you cannot expand it. Okay? Let us write down D is equal to left hand side. Now we will prove this LHS is equal to RHS. So this is your left hand side. Okay. So what is there on the right hand side to be proved? It is 1a square ab a cube, 1a square a cube, second row 1b square b cube, third row 1c square c cube. But here we have in the first row a square bc, b square ca in the second row, c square ab in the third row, right? But you have to make it a square a cube first. You can make it a square a cube, right? A can be made a square by multiplying by a. A square should be multiplied by a to get a cube, but here also you should multiply by a also. If you multiply this first element and the second element of the first row by a, you have to multiply the third element by a also. That means all the terms of this first row should be multiplied by a to get a square a cube. This should be ABC. There is ABC, isn't it? And now this second row should be multiplied by b, and this third row should be multiplied by c to get c square c cube ABC, like that. Okay, because you have to move, you have to make c square c cube, isn't it? But we are multiplying this first row by a ourselves. हामी आफै multiply गर्दैछौँ. We are multiplying second row by b ourselves, and we are multiplying third row by c ourselves. But that should be cancelled. यहाँ a ले multiply गरेर त्यो a लाई cancel गर्नु पर्यो, a by a. यहाँ b ले multiply गर्नु पर्यो, तर त्यो b लाई cancel गर्नलाई 1 by b. यहाँ c ले multiply गर्नु पर्यो, त्यो c लाई cancel गर्नलाई 1 by c. So now how will you write here, right? So therefore d is equal to, अगाडि नै तिमीले यहाँ determinant बाहिर नै abc लेखिहाल्नु, 1 upon abc, but it should be 1 upon abc. This first row is multiplied by a, so you should write 1 upon a. This second row is multiplied by b, so you should write 1 by b. This third row is multiplied by c, it should be written 1 by c, so that you can cancel that a, b and c, right? So now, what is the first row? A square, a cube, and this one is ABC. Is that clear? Next, b square, b cube, ABC. Next one, this becomes c square, c cube, and this one is ABC. I think you are getting my point, isn't it? Now there is in the third column ABC, ABC, ABC. It is common, right? You can take it outside. You can take that common ABC outside determinant sign. Therefore, D is equal to 1 upon ABC into ABC. This ABC from the third column is taken common from the determinant, right? Now what is the first column out here? A square, a cube, and this is 1. As a first column ra second column say remain same. A square, b square, c square, and this is a cube, b cube, c cube, and this third column changes. That means it will be 1, 1, 1. So here you can cancel this common term ABC. That is 1. So what is D now? D is equal to, what is the first column? A square, b square, c square. What is the first column? A square, b square, c square, right? What is the second column? A cube, b cube, c cube, and what is the third column? It is 1, 1, 1, right? Understood? Okay. But we have to prove here 1, 1, 1 should be in the first column, a square, b square, c square should be in the second column, a cube, b cube, c cube should be in the third column. But this is not correct, okay? Let us interchange 1, 1, 1 should be in the first column. Let us interchange first column and the third column, okay? So use problem number 2. So plus signs are minus. Let us interchange first column and the third column. Now third column becomes here first column. Second column remains same, a cube, b cube, c cube. And what is the new third column here? A square, b square, c square. Correct? Now again a square, b square, c square is in the second column here in the question. So again you have to interchange this second column and the third column, so that a square, b square, c square is in the second column and a cube, b cube, c cube is in the third column. So use the same problem number 2. Interchange second column and the third column. So this minus sign becomes plus. So D is equal to 1, 1, 1 second column, a square, b square, c square, and what is the third column? A cube, b cube, c cube. So this is the answer. So we have proved it. So we have proved. So this is question number 11. Copy it. So now we shall do question number 13. Let us prove this LHS is equal to RHS. This is a little bit difficult question out here. So now first row is cos x minus a, cos x plus a, cos x. Second row is sin x plus a, sin x minus a, sin x. And also the third row, cos a tan x, cos a cot x, cos a 2x. We have to simplify it using properties of determinant here also. You cannot directly expand it without expansion. So now let us use property number 5. Let us add these two columns. So why are we adding these two columns? Cos a common, tan x plus cot x. Trigonometry use also, so you can simplify it. Okay. So let us use problem number 5. So first of all, you have to write d is equal to, isn't it? You can copy this question. So you have to prove LHS is equal to 0. So suppose this is d is equal to this one. Okay, you can copy it in your copy, right? So C1 dash is equal to C1 plus C2. That means here this column 1 is changing, right? So therefore d is equal to, now what is the new first column? Cos of x minus a plus cos of x plus a. Then next, sin of x plus a plus sin of x minus a. Then cos a tan x plus what? Cos a cot x. Cos a cot x. And now second column or third column, same. They remain same, isn't it? This is cos of x plus a. Then this is sin of x minus a. Then this is cos a cot x. Cos a cot x. Then what is the last column? Cos x, sin x and cosec 2x. Cosec 2x. Is it clear to all of you? Okay. Now you have to simplify each and every element of the first column. First column को हामी यो प्रत्येक element लाई हामी simplify गर्छौं. Is it clear now? So हामी चाहिँ के गर्छौं अब यसलाई निकालेर गर्नु. Cos of x minus a plus cos of x plus a लाई हामी बाहिर निकालेर simplify गर्नु. यसलाई पनि sin of x plus a plus sin of x minus a लाई पनि बाहिर निकालेर गर्नु. Cos a tan x plus cos a cot x बाहिर निकाल्नु. किनभने e गर्यो भने complicated भएर आउँछ यो determinant. बुझ्नुभयो हैन? So let us simplify the first element of the first column, right? Now this first element, cos of x minus a plus, this is cos of x plus a is equal to, now which formula is used here? Cos c plus cos d. You know that formula in class 11. What is cos c plus cos d? Cos c plus cos d को formula के हो? What is cos c plus cos d? Can you tell me? It will be 2 cos of c plus d by 2 cos of c minus d by 2, right? So this is the formula. So use the formula here. You can use the formula. C here is x minus a, d here is x plus a. 2 cos of, what is c plus d? X minus a, c, d is x plus a divided by 2 cos of अच्छा यहाँ नि c लाई चाहिँ तिमीले ग्रेटर एंगललाई लिन सक्छौ x plus a as c and x minus a as d. Okay, so usually we take the greater number as c and smaller number as d. यसलाई हामी x plus a पहिला लेख्यौं भने plus x minus a पछाडि लेख्ने एउटै आउँछ त यसमा अब c minus d लेख्दा चाहिँ हामी के लेख्छौं पहिला x plus a then minus d. What is minus d? Minus x minus into minus plus a divided by 2. Is that clear? So which is equal to now 2 cos कति हुँदैछ यो here a gets cancels x plus x 2x divided by 2 is x and this one is cos of here you can cancel this xx a plus a is 2a divided by 2 is always a. That means first element of the first column is 2 cos x cos a. यहाँ लेखिराख्ने है त 2 cos x cos a 2 cos x cos a हामीले यो एलिमेन्ट सिम्प्लिफाई गरेर यति पायौं ठीक छ अब नेक्स्ट एलिमेन्ट देयर इज अगेन what is the second element of the first column? It is sine of x plus a plus sine of x minus a. So let us simplify it now. So let us simplify it. In this case, which formula is used? Okay, मैंने cos c plus cos d use गरे. अब हामी use गर्छौं sin c plus sin d. So you have done it in class 11, isn't it? This formula is from the chapter Transformation of Products and Sums. So it is sin c plus sin d. So what is the formula? 2 sine of c plus d by 2 cos c minus d by 2. 2 sin c plus d by 2 into cos of c minus d by 2. That is your formula, right? So use the formula here. 2 sine of what is c plus d? C here is x plus a. X plus a is more than x minus a. That's why you take c as x plus a and d as x minus a. So x plus a plus x minus a by 2 and then cos c minus d, isn't it? That is x plus a minus x minus to minus plus a whole divided by 2, right? So here you can cancel this a gets cancels, here x cancels. So what do we get? 2 sine of x plus x 2x divided by 2. 2 gets cancels x cos a plus a 2a divided by 2 that is a. That means second element of the first column of the given determinant becomes 2 sin x cos a. 2 sin x and then it is cos a. Right? Understood? बुझ्दैछौ? अच्छा अब हामी के सिम्प्लिफाई गर्छौं? Third element of the first column. Again. So what was the third element of the first column? What was it? Cos a tan x. What was it? Tell me. Cos a cot x. Now let us simplify it. The third element of the first column was cos a tan x plus cos a cot x. So what is common here? It is cos a within bracket. What do we get? Tan x plus cot x. Now let's simplify it. So I think you have understood these two. When you see the formula, that formula is cos c plus cos d and sin c plus sin d. But in this case we are taking common here. Cos a is taken common, so within bracket we have tan x plus cot x, right? So let us simplify it now. So which is equal to cos a? What is tan x? You know that sin x by cos x plus what is cot x? It is cos x by sin x, right? So which is equal to cos a within bracket, what's the LCM? Take the LCM and simplify it. It is sin x cos x is the LCM, isn't it? Now this LCM is divided by cos x. Cos x, cos x cancels. Sin x into sin x is sin square x plus. Again, this LCM is divided by sin x. Sin x gets cancelled. We will get cos x. Cos x into cos x is cos square x. Is that right? Okay. So which is equal to cos A into, now you know this formula. What is sin square x plus cos square x? 1 divided by sin x cos x. Is that right? Okay. Now here this is sin x cos x. I think you know this expression, sin x cos x. In multiple angles, in trigonometry in class 11 you did it. That is, what is the formula for 2 sin x cos x? What is the formula? What is the formula for these 2 sin x cos x? Is equal to, what is the formula? This is sin 2x. We should use this formula. But what is missing here? 2 is missing. So you have to multiply it by 2. But we are multiplying ourselves by 2 here. That should be cancelled. So you have to multiply the numerator by 2 also. So multiply and dividing by 2 is equal to cos A into 2 divided by 2 sin x cos x is equal to cos A into 2 divided by, what is the formula for 2 sin x cos x? It is written there. It is sin 2x is equal to 2 cos A into what? What is 1 by sin 2x? It is cos A 2x. So I think you have understood it. तिमीले बुझ्यौ होला त जुन चाहिँ यो तिमीले प्रपर्टी युज गरेर c1 dash is equal to c1 plus c2 लेखेका छौ त्यसमा column 1 is changed. The third element of the first column is now simplified and we got this expression, that is 2 cos A into cosec 2x. Is that clear now? So now we will write all these simplified form in the determinant. So therefore D is equal to, in the last determinant I think there was, in the first column, that is first element of the first column was cos of x minus a plus cos of x plus a, isn't it? So what is the simplified form? It was 2 cos x cos a. 2 cos x cos a, right? And the next one was sin of x plus a plus sin of x minus a. Sin of x plus a plus sin of x minus a. And its simplified form was 2 sin x cos a. 2 sin x cos a. And the last one was first column, new first column को last third element चाहिँ के थियो? cos a tan x plus cos a cot x थियो. त्यसलाई हामीले सिम्प्लिफाई गरेर यति निकाल्यौं. यहाँ लेख्नु 2 cos a into cosec 2x. Cosec 2x. Is it clear now? Now this is the new first column. The second column and third column remain as it is. What was the second column? Cos of x plus a. Cos of x plus a, right? Cos of x plus a, then comes sin of x minus a. Sin of x minus a, then comes cos a cot x. Cos a cot x. Then comes cos a cot x. And what was the third column? Cos x, sin x, and cosec 2x was there. Cosec 2x. So now first column is simplified. जुन चाहिँ हामीले न्यू फर्स्ट कलम निकालेको थियौं c1 plus c2 गरेर त्यसलाई नै हामीले सिम्प्लिफाई गरेर u निकाल्यौं. Right? So now D is equal to, now in the first column there is common. What is common? What is common there? 2 cos a, 2 cos a, 2 cos a is taken common now. 2 cos A is taken common. So now within determinant, what is the new first column? 2 cos A is taken common, cos x. This is sin x. And this is cos A 2x. Right? So this is the new first column. And second column and third column remain same. Cos of x plus A, sin of x minus A. This is cos A cot x. Right? This is the second column. And third column also remains same. Third column पनि same बस्छ. Cos x, sin x, cos A 2x. Is that clear to all of you? Okay. Therefore, D is equal to 2 cos A into, what is the value of this determinant? Without expansion, you can write it. What is its value? It is 0, isn't it? Because first column and third column are same. Cos x, sin x, cos A 2x, cos A 2x. What is the value of the determinant? 0. That is D is equal to anything into 0 will be 0. So here हामी लेख्न सक्छौं, since two columns are identical. Since two columns are identical, proved. Is that clear to all of you? So you can copy it, you can practice at home. Okay? Now, I'll give you the homework. मैले यहाँ जुन नम्बर गरिन म त्यो चाहिँ तिमीलाई होमवर्क दिन्छु. त्यो होमवर्क म यहाँ लेखिदिन्छु, तिमीले सार्नु ल. So you can copy it. Now, I'll write down the homework. I'll write down the question. You can do it at home. Okay? So now, this is your homework. Okay? You can do it at home. That is page number 174, same exercise. Okay? So you have to prove it without expanding. Okay? Prove without expanding. So in this problem also you cannot expand. You have to expand, you have to prove it without expanding. That is question number 8, question number 10, question number 14 and question number 15. You can copy it and then prove it. If you can't do any problem, you can write on the comment or you can call me. Okay? Then I will solve it for you. I think you can do it. मलाई जति सक्दो लाग्छ तिमीले यो गर्न सक्छौ होला सायद, तर कोशिश गर्नु भएन भने मलाई सोध्दा हुन्छ. ठीक छ? तर आजलाई हामी यति नै गरौँ. फेरि नेक्स्ट क्लासमा म अर्को सेक्सन गराउँछु. दैट इज each question carries 4 marks. ओके? त तिमीको यो जुन चाहिँ डिटरमिनेन्ट च्याप्टर छ, यो डिटरमिनेन्ट च्याप्टर अब्जेक्टिभमा कोही बेला दुईटा आउन सक्छ, कोही बेला एउटा आउन सक्छ. इच क्यारी क्वेसन 1 मार्क. अनि तिमीको यो डिटरमिनेन्ट 2 मार्क्स को आउँछ. इन सर्ट एन्सर टाइप क्वेसन अनि लङ एन्सर टाइप क्वेसन. यसलाई सर्ट एन्सर टाइप क्वेसन भन्छ हामी, लङ एन्सर टाइप क्वेसन भन्छ. यो 4 मार्क्स मा पनि आउन सक्छ. बुझ्यौ? यो डिटरमिनेन्ट क्वेसन 4 मार्क्स मा पनि हुन सक्छ, 2 मार्क्स मा पनि हुन सक्छ अनि 1 मार्क मा पनि हुन सक्छ. बुझ्नु छैन? त यो चाहिँ सबै 2 मार्क्स सेक्सन को. अब नेक्स्ट क्लास में चाहिँ हामी के गर्छौं, 4 मार्क्स सेक्सन गर्छौं. अलिक लामो, अलिक अप्ठ्यारो हुँदै जान्छ अब चाहिँ. बुझ्नु छैन? त्यही कारण तिमीले घरमा रिभिजन गर्नु, राम्रोसँग गरेर प्र्याक्टिस इट एट होम, रिपिट. ओके? त यदि तिमीले यो यसमा बुझेन भने यु क्यान रिपिट द भिडियोलाई तिमीले बारम्बार रिपिट गर्दै पनि हेर्न सक्छौ. बुझ्यौ? अनि यो प्रब्लम पनि कपी गरेर तिमीले होमवर्क गर्नु. बुझेन त? So this much is for today. Stay home, stay safe. Okay?